Yeah. No? All right. All right, now, Matt Shelton, what'd you get for number 18? Yeah, that's correct. We did number 20 in class. Caleb, what'd you get for 21? 2 and 9, yeah. Zach, what'd you get for 22? You got what? Yeah, that's correct. 23. Larry, what'd you get for 23? That is correct. 25. Who got 25? Oh, 25 we did in class, correct? Yeah, 25 we did in class. Okay. All right. So let's look at continuing on with what we were doing, obviously. Let's look at 28. I want to do a couple of more examples, and then obviously we'll move on to what we got to do in 7.3 today. 28 says negative 3a plus b equal 4, and then negative 9a plus 5b equal negative 1. Okay, either one of them, it's let's see, did I do that right? Yeah. This one here is probably the easiest one to solve. To solve for b would probably be the easiest thing to do. So that would be b equal 3a plus 4. Okay, so if we plug in what we have for b into the other expression, then we get negative 9a plus 5 times 3a plus 4 equal negative 1. Okay, so we substituted in this for the b that's right there. Okay, so if we take this further out, change it back to normal. Negative 9a plus 15a plus 20 equal negative 1. In other words, I just distributed the 5 to both things inside the parentheses. I can put those two together. That gives me 6a plus 20 equal negative 1. Okay, obviously negative 9 plus a positive 15 gives me 6. So I'm going to take the 20 over to the other side, and it becomes negative 20, and I'm adding it. So it would be 6a is equal to negative 21. Now I have to divide by 6. Divide by 6, not negative 6, excuse me. And that gives me what? A would be equal to what? But we got to reduce it. Negative 7 over 2. So negative 7 over 2, which is 3.5. So there's your first one. A is equal to negative 3.5. Okay. Now I'm going to take that and plug it back into my revised equation. So that's going to give me b is equal to 3 times 3.5, negative 3.5, plus 4. Okay. Now, when I take 3 times 3.5, you basically have this. And then plus 4. And so that's going to give me negative 21 over 2 plus 4. 21 over 2 is what? 10.5. So negative 10.5 plus 4 would give me negative 6.5. So B is equal to that. So your 2 points then are negative 3.5 and negative 6.5. And that would be your answer. Yeah, Owen. Do what? Negative. Negative 1. Oh, yeah, that was my equation up here. Right there. All right, now, let me see here. There's one in here. Yeah. We haven't really talked about any that have fractions in it, so I want to do one that has fractions in it. We have x plus y equal 12, and then my other equation is x plus 3 halves y. Yeah, 3 halves y equal 3 halves. Now, the first thing I'm going to do here is I'm going to take and multiply everything here by 2. I'm multiplying everything by 2 to get rid of the fractions. Okay? That gives me 2x plus those 2 cancel out, giving me 3y equal those 2 cancel out, giving me 3. Okay, I just did that to get rid of the fractions. Okay, now I'm going to come over here and solve this equation for x, or excuse me, for y, which means I have y is equal to negative x plus 12. Now I'm going to take this and plug it in over here for my value for y. So it gives me 2x plus 3 times negative x plus 12 equals 3. Okay, now we have to distribute the 3 to both things in the parentheses, giving me 2x plus negative 3x plus 36 equal 3. Excuse me. So that gives me negative x plus 36 equal 3. Because I combine those two together and get negative x. Now I'm going to take the 36 over to the other side. It becomes a negative 36. So that gives me negative x is equal to what? Negative 33. So that means x is equal to 33. Everybody understand where I got that? I just took and knocked those two out. Because we can't have negative x, it's got to be x. So if the opposite of x is equal to negative 33, then x would have to be equal to positive 33. Now I'm going to take that 33 and plug it back in up here where the x is. Okay, and when I do that, that gives me y is equal to negative 33 plus 12, which means y is equal to what? Negative 21. So 33 and negative 21 is your point, your solution point. Yes, sir? Most definitely. 34? Why do we need to do 34?
Because if you have 1/8 and 3/4, what do you multiply if you cancel most of it?
What's the common denominator between 8 and 4? 8, so you just multiply everything by 8, and that'll get rid of it. At the bottom equation, you just multiply everything by 2. So that'll help you get rid of that.
Can you multiply by 16?
Huh?
Can you multiply by 16 instead of 8?
Do what now?
Can you multiply by 16 instead of 8?
You could, but you're going to create larger numbers that eventually you'll have to reduce down. That's why you always want to anytime you're trying to get rid of fractions, you always want to multiply it times the common denominator, and that'll help you out. All right, now let's move on to 7.3. We may come back to 7.2. Let's move on to 7.3. Okay. 7.3 is solving linear systems by linear combinations. This one is fairly simplistic. Okay. We're going to do 3 things. We're going to use addition to combine linear systems. We're going to use multiplication to combine linear systems. And we're going to combine like terms. Okay? So it's sort of combine like terms to use combinations for linear systems. Okay? All right, now, the easiest one is using addition. Actually, let me change that to arranging. That's what the word the book's going to use. So arranging like terms. All right, the easiest one is to use addition to solve linear expressions. Okay, now let me show you what I mean. All right, let's say we have these 2 equations. 3v minus 2w equal 1, and 2v plus 2w equal 4. Now, when you're talking about combining or using combinations to solve linear systems, basically you're going to put the 2 equations together. So I'm going to take 3v minus 2w equal 1, and I'm going to line up 2v plus 2w equal 1, or equal 4. And I'm going to combine those by adding them. I'm going to combine those 2 equations by adding them. In all of these, we're going to eventually add them. Okay? But in some of them, we're going to do a couple other steps before we do the adding. Well, right here you can see that I have the opposites there. Okay, because remember, this is plus a negative. So I'm going to add this up, 1 plus 4, which is 5. Then I'm going to take these 2, and they cancel each other out, leaving me with one variable. 3v plus 2v is 5v. So now I solve 5v equal 5. That means v is equal to 1. Okay? Now, I take and I plug that 1 into either equation that I started with to get what w is. Okay? So, let's see here. Let's plug it in over here. We're going to plug in that 1 right there. So that gives me 2 times 1 plus 2w is equal to 4. And that would be 2 plus 2w equal 4. So now I'm going to take this 2 over to the other side. It becomes negative 2, which means I have what? 2w equal 2, which w equal to 1. So 1 and 1 is my solution. Do what? What do you mean, same thing? I'm going to show you those. We'll get to those in a second. All right. Let me look at one here, like this one here. Let's do 14. 14 says 1/2 g plus h equal 2. And then the other equation is negative g minus h equal 2. Okay, and so we stack them on top of each other. Okay, I just went ahead and changed that right there when I rewrote it. And so now, you combine them, you have 4. Those two cancel, and that gives me negative 1/2 g. Okay, so to solve, I want to solve this. So negative 1/2 g equal 4. To solve that, I must take and multiply by the reciprocal to both sides, which g is equal to negative 8. Okay? Now, once again, you can plug it into either equation. It doesn't matter. I'm going to plug it into this equation, so I don't have to deal with the negative h over on the other one. It will come up to be the same thing, but I'm just going to do it here. So that means I have 1/2 times negative 8 plus h equal 2. So that's negative 4 plus h equal 2. Negative 4 to the other side becomes positive. Oh, excuse me, 2. I got ahead of myself. I actually wrote the answer. Okay. H equal x. E, F, G, H, I. So for those of us that know our alphabet, negative 8 and 6 would be your solution to the problem. Okay, now, let's look at, that's just the straight addition. Let's look at multiplying before combining. Okay, so we're still going to combine them, but these have a little bit different. And what we're trying to do is let's take, for example, let's look at number 16. Okay, number 16 says x minus y equals 0. And I'm just going to go ahead and stack them on top. Negative 3x minus y equal 2. There it went. All right, now, there are several different ways that I can, and what I'm doing by combining them, I'm trying to get rid of one of the variables. Okay? So there are several different ways that I could do this problem. I first of all could do this. I could multiply the top expression by 3. Okay, if I do that, then that gives me 3x minus y equals 0, or excuse me, 3y, minus 3y equals 0. And on bottom, I would have negative 3x minus y equal 2. Okay, that's one way that I could get rid of it. Okay, another way that I could get rid of it is this way. I could take x minus y equals 0, and then on bottom, negative 3x minus y equal 2. I could take and I could multiply everything on bottom by negative 1. Okay, if I did that, that would give me x minus y equals 0, and on bottom it would give me 3x plus y equal negative 2. Okay, either way, you're still going to eventually get the same answer. Okay, so it's just a matter of which one you can see the easiest and do that. Okay, for one person it may be one, maybe the first one up there. For 4 or 5 of you, maybe the second one I did. Okay, but they will both yield the same answer providing that your mathematics are correct. So the whole part of it is to try to eliminate one of our variables. Okay, Caleb?
On the first one, why, if you multiply all the top line by 3, do you take out the 3 or do you leave negative 3x still there?
Well, that's coming in a second. I just wanted to show you what the problem is once we, yes, up here, you're going to end up canceling those two. And that gives me, if I add these two together, that gives me 2. If I add these two together, that gives me negative 4y. And then the x's cancel out. Same thing over here. If I add this one up, that gives me negative 2. These two cancel, giving me 4x. Okay, and I'm going to show you that it's going to equal this. And bottom line is, realistically, if I've done it both ways, now I'm going to get both answers without having to plug anything in. Just showing you the two different ways to do it. Okay, if you divide by negative 4 here, that gives me y is equal to negative 1/2. If I divide by 4 over here, let me change colors there so we don't think it's a part of the problem. If I divide by 4 here, that gives me x is equal to negative 1/2. So your answer is negative 1/2, negative 1/2. So showing you the two different ways you could set it up, we end up solving the problem without having to plug in. Like I could have come here and I could have plugged this in for the y, over here. But you want to, when you plug in, you want to plug it into the original equation. Okay? You want to plug the negative x here for y needs to go in here or here, not into the one that we adjusted there. Okay? So let's look at another example of the multiplication. Let's look at number 20. Number 20 says 2p minus q equal 2, and 2p plus 3q equal 22. Now, what's one way that I could get rid of one of the variables in this? Matt?
You multiply the bottom one by 2?
Multiply the bottom one by 2?
Oh, no, the top one.
Multiply the top one by 2, and what is that going to get? How is that going to get rid of anything? We're multiplying. You know, if I multiply by 2 to the top, that gives me 4p minus 2q equal 4, and that doesn't get rid of one of my variables. Zach? Is that not what I put? Yes, it should be. I don't know why I put a plus there. That should.
Oh, could you use -1?
Yes, you could use -1 to either one of the problems. I can multiply by -1 to either the top one or the bottom one. That's one way to get rid of it. What's another way?
Do you really have to multiply? Because all you have, because don't we just get rid of the two 2p's?
They're not different. That's 2p plus 2p. That's that, which is 4p. So it doesn't get rid of it. So yes, we have to multiply it by something. Now, what Matt said is correct. I can multiply either one of them by -1. Okay? The other thing that you could do, the two things that you could do is multiply either one of them by -1, or I already have an opposite right there, correct? So I would need to have a 3 right there to get rid of it that way. So the other way that you could do this one is multiply the top one by 3, and that would get rid of one or the other as well. The easiest way to do it is just take and multiply the top by -1. So I'm going to multiply by -1 to everything right there. Okay, when I do that, that now gives me my new one is -2p plus q equal -2. And on bottom I have positive 2p plus 3q equal 22. Now I can add it together. Okay, so that gives me 20 equals 4q, and those two cancel out. And so that gives me q is equal to what? 5. Now I'm going to take the 5 for q, okay, and I'm going to plug it back in to one of the original equations. I'm going to plug it into this equation. And so that gives me 2p minus 5 equal 2. Okay, I just took this 5 and plugged it in for that right there. So that's plus a negative. So I take the -5 over to the other side. It becomes a positive 5, which makes that 7. That gives me 2p is equal to 7. So I have to divide by 2, divide by 2. P is equal to 3.5. So once again, for those of us that have trouble with our alphabet, 3 1/2 and 5.
Oh, you got 2, not 22.
Really?
No, I put 27. Like I added the wrong.
All right, I want you to do 24 on your own.
Can we do it on the board?
No, because we got other stuff to still cover. 9x minus 3z equal 20, and 3x plus 6z equal 2. Let's look at this one. As I stated, there's two different ways you could do it. Probably the easiest way is just to multiply everything by 2 here. Okay, and so that gives us 18x minus 6z equal 40. And then underneath we got 3x plus 6z equal 2. We add them together, we combine them by adding, and that's 42 equal, those cancel, 21x. So I divide by 21, divide by 21, that gets me x equal to 2. So if x is equal to 2, then I can plug that 2 into that equation, and so that gives me 3 times 2 plus 6z equal 2. That would be 6 plus 6z equal 2. Take that 6 over to the other side, becomes negative 6, which is negative 4. So that's 6z equal negative 4. Divide by 6. Divide by 6. Z is equal to negative 2/3. And so it's 2 and negative 2/3. Okay. All right. Last one. Arranging terms. Okay. And realistically, this one is just they just add another step to it. Basically, is all they're doing. Okay. For example, look at 26. 26 says 3b plus 2c equal 46. I'm not even going to write the equation underneath it because it's all jacked up. So we're just going to put it over here. Okay. So does the b come first in the second equation? No. So you just basically you're doing this. You're taking the two equations and saying 3b plus 2c equal 46 and b plus 5c equal 11. Okay, now I've arranged the terms, but I'm still not able to get rid of anything. Okay, so now you've got to use one of the two ways, either the multiplication or just by adding opposites. So I'm going to use the multiplication. And what I'm going to do is I'm going to multiply the bottom part by negative 3. And that gets me 3b plus 2c over equal 46, and then negative 3b plus negative 15c equal negative 33. Now I'm going to add them. Okay, so we arranged the terms. We arranged there, and then we multiply to combine. Okay, and now we're going to add the things together. That gives me no b's, and then it gives me negative 13c is equal to what? Negative 13, isn't it? Or 13, positive 13. So then that gives me divide by negative 13, divide by negative 13, and that gives me c is equal to negative 1. Then I plug that in to one of my original equations. I'm going to plug it in up here. And so that gives me 5 times negative 1 plus b equal 11. Well, that's negative 5 plus b equal 11. Take the negative 5, it becomes a positive 5 over there, which gives me b is equal to 16. So you have 16 and negative 1. Sort of blows you out of the water, doesn't it there, Blair? All right, let's look at 30. We haven't done with these decimal ones yet. All right, number 30 says 0.1g minus h. All right, look. I want you to look at something here. All right. If you will do this, first of all, multiply everything by 10. Okay, that will get rid of your decimals. So that gives you 1g minus h plus 43 equals 0. And then you have 36 equal 2g plus 10h. Yeah, excuse me, 10/8 there. All right, so you have your homework.
When do you have tutoring?
Tomorrow morning.